In the previous video, we looked at pure gases. What happens when you have a mixture of gases? Air is mostly nitrogen. We use oxygen in respiration. Note that carbon dioxide is about 0.04% now. Air is the source for oxygen. Stop the video and answer this question. And the answer is, air is cooled to liquid air. Then we use the difference in boiling point to separate the oxygen from the other components. For a gas mixture, the total pressure equals the pressure of the individual components. That's called the partial pressures. The partial pressure of a component equals the mole fraction of that component times the total pressure. Let's do an example. What's the partial pressure of nitrogen and oxygen in the air in Salinas? Air is 78% nitrogen, so the mole fraction of nitrogen is 0.78. So the partial pressure of nitrogen is 0.78 atmospheres. Stop the video and figure out the partial pressure of oxygen. And the answer is, does the partial pressure of O2 and N2 change when we go to Lake Tahoe? Stop the video and calculate the partial pressures. Note that the atmospheric pressure in Tahoe is 0.85 atmospheres, which is lower than Salinas. And the answers are, our bodies work best when the partial pressure of O2 is about 0.2 atmospheres, so when we go to higher elevation, we got to acclimate our bodies. Here's a really high elevation. Stop the video and calculate the partial pressure of N2 and O2 on top of Mount Everest. And the answers are, it takes quite a bit of acclimating to get accustomed to these partial pressures. The amount of water in air is the humidity. Your favorite weatherman often reports the relative humidity. Relative humidity is the partial pressure of water in air divided by the vapor pressure of water in air at that temperature. Here's what vapor pressure is. Some molecules at the surface of a liquid have enough energy to escape to the gas phase. Some of those gas molecules return to the liquid. The pressure those gas molecules exert on the surface of the liquid is called vapor pressure. Vapor pressure changes with temperature. Stop the video and answer this question. And the answer is, the higher the temperature, the more liquid molecules escape to the gas, which means more gas molecules exert pressure on the surface of the liquid. This table shows that as temperature increases, vapor pressure of water increases. Note that at 100 degrees, the vapor pressure equals the atmospheric pressure. So boiling point is the temperature which the vapor pressure of a liquid equals the atmospheric pressure. Now that we know something about vapor pressure, stop the video and answer these two questions. And the answers are, some molecules at the surface of a solid escape to the gas phase, although a lot fewer in a solid than a liquid. Acetone is more volatile than water, which means acetone has a higher vapor pressure than water at the same temperature. There are weaker intermolecular forces between acetone molecules, which makes it easier for acetone molecules to escape to the gas phase. Let's take a look at some of the terms used in a weather report. Stop the video and answer these questions. And here are the answers. For part C, let's take a look at the relative humidity equation. The relative humidity is 90%. The vapor pressure of water at 30 degrees is 31.82 torr. Let's solve for the partial pressure of water. When the temperature drops 25 degrees, the new vapor pressure of water is 23.76 torr. Assume the partial pressure of water does not change, so the new relative humidity is, and we'll get rain. And for more weather, the winds blow when there's a difference in pressure. The winds blow from high pressure to low pressure. Tire manufacturers recommend you check the air in your tires frequently. If one or more tires is below the recommended pressure, do you fill your tires with air or nitrogen? Stop the video and think about that for a minute. Here's some information. Oxygen is smaller than nitrogen and passes through rubber faster than nitrogen. So you'll have to decide whether it's worth the extra expense to fill your tires with nitrogen compared to air. The noble gases xenon and argon can enhance the oxygen carrying capacity of blood. So the World Anti-Doping Agency has banned the use of xenon and argon for athletes. In lab, we're going to see how popcorn pops and calculate the gas pressure inside a popcorn kernel before it pops. Here's a hint. We'll use this equation to estimate the pressure. Popcorn kernels must have around 15% water to pop. Otherwise, you get old maids. If you like microwave popcorn, check to see what the butter flavor is. There are quite a few areas that don't get enough rain. Silver iodide could serve as a seed to help form ice nuclei that can fall as rain or snow. Lucky for us, ice floats on water. It would be bad for life if bodies of water froze from the bottom up. We know there's hydrogen bonds between water molecules. In ice, Hydrogen bonds separate the water more than in the liquid. That greater spacing results in a lower density for ice. SLAC stands for Salinas Linear Accelerating Corks. In lab, you're going to mix baking soda and vinegar and try to propel a stopper as far as you can. To propel that stopper, you want the pressure inside the flask to be as high as possible. For your experimental variables, should the moles of gas be high or low? Should temperature be high or low? What about volume? Try something, see how it works, then try something else, see if it works better.